This how-to video looks at how we can measure enthalpy change of combustion in the laboratory, and for illustrative purposes I'm using the reaction detailed here. What I'm going to do is I'm going to run the sequence through and make the observations as it goes. The first part of the calculation we need to do is to work out how much energy burning 0.46 grams of ethanol actually gives to the water. And once again we use this general formula which is often used in enthalpy experiments and enthalpy calculations, and it is energy equals mc delta T, where m represents the mass of whatever substance is changing temperature. In this case it was water. C refers to the specific heat capacity of the substance changing temperature, and delta T is the temperature change. So in this case we have water of 50 centimeters used, and that is equivalent to 50 grams because water has a density of 1 gram per centimeter cubed. The specific heat capacity of water is 4.18. But you don't have to worry about this because in every exam question or every situation where you're presented with one of these problems, you will always be given the specific heat capacity, and the temperature change is what we've measured in this experiment. In this case it's 28 degrees. So let's just plug those into this equation and see what we get. So 0.46 grams of ethanol produces 5852 joules. But of course what we really need to do now is to relate this to the equation, and if we look at the equation, what does the equation say? It says, well, 1 mole of this reacts with 3 moles of oxygen to make 2 moles of carbon dioxide and 3 moles of water. So how do we proceed? What we've got to do is we've got to turn this number into an expression which relates to this equation. So we've got to turn this number into the energy given per mole of fuel. And the way we do that is we work out the number of moles of ethanol, in this case, in 0.46 grams. And we do that using the general formula that moles equals the mass of the substance divided by its relative molecular mass. In this case, the relative molecular mass of ethanol is 46. So if we divide 0.46 by 46, we arrive at the number of moles used in this expression as 0.01 mole. So putting that into words, 0.01 mole produces 5852 joules. So to get the joules per mole, we need to divide this number by the number of moles we've used. So after the final calculation, we've got the 5852 joules divided by the number of moles of ethanol, which is 0.01, which gives us 585200 joules per mole of ethanol. And the convention is to turn the joules into kilojoules where possible. So that gives us, we divide this number by 1000, which gives us 585.2 kilojoules per mole. So in summary, in this reaction, the combustion of ethanol, the standard enthalpy of combustion under the conditions that we've had in the laboratory is equal to minus 585.2 kilojoules per mole. The minus sign indicates, as we know, that this is an exothermic reaction. And I hope that's helpful. Thanks.